Welcome to The Explainer. Today, we're diving into a fascinating strategy that quietly powers so much of our world, from your internet connection all the way to massive global supply chains. It's a way of thinking that promises the best possible result by always making the simplest choice. But does that promise hold up? Let's get into it. Think about it. It's a classic problem, right? You have to make a choice, but you only have the information that's right in front of you. We all do this every day, trying to find the best path forward without knowing what's around the corner. Well, it turns out that computer science actually has a formal name for this kind of on-the-spot decision-making. And it's a strategy that is both incredibly simple and, as you'll see, sometimes shockingly powerful. All right, let's start with the basics. Section 1, the greedy choice. A simple, powerful idea. So what exactly is a greedy algorithm? Well, at its core, it's a strategy that lives completely in the moment. And every single decision point, it just asks one question. What's the best move for me right now? It grabs that immediate win, the locally optimal choice, and hopes that stacking up a bunch of these small wins will lead to the best overall outcome. Let's use an analogy to make this crystal clear. Imagine you're a hiker. Your goal? To reach the highest peak in a huge mountain range. Now, a greedy approach means you're not using a map. You're just looking at the ground right in front of you. And at every fork in the path, you always take the one that goes uphill the steepest. It feels like you're making progress, right? But where is that path actually taking you? Section 2, algorithms in the wild. And here's the thing. This isn't just some abstract theory. This greedy way of thinking is humming along behind the scenes all around us, in way more places than you might think. Honestly, the sheer number of applications is kind of mind-blowing. The data packet for this explainer getting to you right now, probably guided by a greedy choice, hopping from one router to the next. The delivery truck that dropped off your last package, its route might have been planned using a greedy algorithm. It's even used in urban planning. A study in Rotterdam actually used it to figure out the best places for ambulance stations to save lives. From finance to compressing data, it's a real workhorse of modern tech. And they're not just simple, they are seriously effective. For example, some research into wireless communication systems found that using a greedy algorithm could boost throughput, that's the amount of data that gets through successfully, by over 40%. That is a huge leap in performance from such a straightforward approach. So, on to section 3, a local peak problem. Because you knew this was coming, right? It can't all be that good. This incredible speed and simplicity, it comes with a hidden catch, a flaw that's baked right into the core of greedy thinking. And this is the million-dollar question. If greedy algorithms are this fast and this easy to build, why aren't we using them for absolutely everything? What is the downside? What's the trap? This really gets to the heart of it. Let's go back to our hiker. By always choosing the steepest path right in front of them, that's the local optimum. They might race up a small hill really fast, but in doing so, they could completely miss the much longer, gentler path that actually leads to the global optimum, the true highest peak in the whole range. They get stuck on a little hill, thinking they've won. And here is the fundamental warning, the key takeaway. A series of what seem like perfect, logical, short-term decisions can add up to a really bad long-term result. The best choice now is not always the best choice overall. Section 4, when greedy fails. And this is not just a theoretical problem. Let's dig into a classic example where this whole approach doesn't just come up short, it can fail in the most spectacular way. Let's talk about the famous traveling salesman problem. It's one of the big puzzles in computer science. The challenge is simple to state. You have a list of cities, and you need to find the absolute shortest route that visits every single city once and then gets you back home. So a greedy way to tackle this is called the nearest neighbor approach. It's exactly what it sounds like. You start in one city, and you just travel to the closest city you haven't been to yet. From there, you go to the next closest unvisited city, and so on. At every step, it feels like the smartest move. But what often happens is you paint yourself into a corner, leaving one last city that's now a horribly long and inefficient trip all the way across the map, completely tanking your total distance. And you don't have to take my word for it. Researchers Gregory Gutton and Daniel Karapetyan put it bluntly. They warn that a greedy approach isn't just sometimes a little bit off. In certain cases, it is a very bad option and can be among the worst possible options. Just let that sink in for a second. The research shows that for some problems, a greedy algorithm doesn't just find a bad solution. It can find the unique, single, worst possible solution. That's like our hiker not just getting stuck on a small hill, but actively choosing a path that leads them straight to the bottom of the deepest canyon in the park. So, Section 5, the right tool for the job. After hearing all that, you're probably thinking, okay, so greedy algorithms are just bad then. And the answer is no, not at all. The real lesson here is about seeing them for what they are, a specific tool for a specific job. It's all about having a balanced view. The big takeaway isn't to just avoid them completely. The key is to be smart about when and how you use them. It's about looking at the problem you're trying to solve and asking that critical question. Is good enough right now okay? Or do I absolutely need the perfect answer no matter how much time or effort it takes to find it? It really just boils down to this fundamental trade-off. On one side, you've got amazing speed. You get an answer right now, when other methods would still be calculating. And they're simple to build. But on the other side, you're giving up any guarantee of getting the best answer. You risk getting a subpar solution, or, as we've seen, maybe even a terrible one. It's speed versus perfection. And so in the end, their true power is their pragmatism. In the real world, the cost of finding that perfect solution can be way too high. We don't always have infinite time or infinite money. Sometimes a fast, simple, good enough answer is not just an option, it's exactly what we need. So, I'll leave you with a final thought. Think about your own day. When you're driving and you switch to the lane that looks like it's moving faster, or you walk up to the shortest looking checkout line at the grocery store, you're running your own little greedy algorithm. So how often do you use that greedy thinking in your own life? And where has it ultimately led you? Thanks for joining this explainer.